Hey, hi YouTube. I hope you all guys are doing great. In this video, we are going to see about Runnable interface in Langchain. In previous video, we have seen about LCEL, where I have promised you that I will bring videos on Runnable interface, which is interesting and also important part. So let's see what actually Runnable interface are in Langchain. So the Runnable interface in Langchain is designed to standardize the way you create and use custom chains. Like many components in Langchain, like such as chat models, LLM, output parsers, retrievers, and prompt templates implement this interface, making it easy to define and invoke custom chains consistently. So basically it is a standard interface which makes it easy to define custom chains as well as invoke them in a standard way. The standard interface includes a lot of methods, like in previous video also we have discussed some of them, like one of them is stream. So the purpose of stream is to stream back the chunks of the response in real time. So example, it can be if you have a large text generation task, you can start receiving parts of the text as they are generated instead of waiting for the entire response. So let me show it. So here I have been just using GPT 3.5 Turbo. So here we are doing the streaming. So we are getting the chunks from model.stream. Basically this stream is also a part of LCEL, the way we create this declarative syntax. You can also use this, you can also implement this stream functionality without LCEL, but definitely if something has already been there, then why you need to code it. Okay, so we are asking a question, write a poem on humans. So whatever chunk we are getting, we are printing it, and then just a basic syntax, okay, to add an end line and flush. Okay, so let me run it. So see how it is coming, like it came with an animation. Let me show you it again, just watch it carefully. Okay, so this is what streaming is. So it stream back the chunks of the response in real time. Okay, so this is what streaming is. Then second one is invoke. So I hope you all guys are already aware about invoke. Okay, so the purpose of invoke is to call the chain or a single input. Example, for a QA system, you can get the answer by invoking the chain with a question. So for invoking, this is a very easy part. Okay, model.invoke and like write a poem on human, and whatever response we are getting, it's a AI message. In previous video I have talked that the output of model is a AI message object, so it has content in it, so this content is being printed. Okay, then we have batch. So batch is like call the chain on a list of inputs. Okay, here it was a single input, but in batch we have multiple inputs. So this is like res model batch, and we are having two questions, write a poem on human and write a poem on animals. So it will return a list, so we are printing the list one by one. So first one will be for a poem on humans, and it is ending here, and then we are having a poem on animals. So here we are getting the poem on animals. So if I make it scrollable, here you can see, and then at the end it is ending. Okay, there are a lot of also asynchronous methods like stream. So a stream, I'm not going to talk a lot about it, but I guess in the video only I will show you at the end a stream, a invoke. Okay, so these all are asynchronous methods. So a stream is like stream back chunks of the response asynchronously. Like example, using async here to handle text generation without blocking other tasks. Okay, a invoke is like call the chain on a single input asynchronously, get an answer to a question like asynchronously. Okay, then we also have a batch. Okay, all of things which are having a in the prefix is like asynchronous. So a batch is like call the chain on a list of inputs asynchronously and process multiple questions at once. Okay, then we also have advanced streaming. Okay, these are very basic things. You can also run it on your own the way I showed for stream and invoke. But we also have some advanced streaming like a stream log. Okay, this is a good one because the purpose of a stream log is like stream back intermediate steps as they happen in addition to the final response. So if I think of an example like useful for debugging or understanding how a chain arrives to its final response. It's really important. You might not feel the use of this stream log currently, but whenever you will do the development part of GenAI or LLM, then you will feel it. Then we have stream events. This is also really important, and I will cover some part of this stream event in this video, and I can have a dedicated video because it's really important and a lot of things are there to understand in it. So the purpose, it is in beta feature that streams events as they happen in the chain. Okay, like you can see in each step what actually is happening. Okay, I will show it. So it monitors the real-time events during chain execution for more granular insights. This is really important. These both are really important. Okay, and this is actually in beta feature, so I will show it. Okay, so if I want to summarize this runnable interface, don't worry, we will see the coding part. Okay, so if I summarize the runnable interface, so it provides a consistent and flexible way to create and use custom chains in Langchain. Okay, with synchronous and asynchronous methods. It supports real-time streaming, single input processing, batch processing, making it easier to handle various tasks effectively. Okay, so like the input and output type can varies by component to component. Like we can have different component, like we can have a prompt component. Okay, so we can have a prompt component. Okay, we can have chat model as a component, we can have LLM model as a component, we can have output parser as a component, we can have retriever as a component. Okay, and all these things have a different input type. Like for prompt we need a dictionary, for chat model we need a string, for LLM we again need a string or list of chat messages. Then for output parser, the output of an LLM or chat model is the input for output parser, and for retriever we have a single string, and we also have the output of it. Like for the prompt, the input is like the dictionary and the output is prompt value. Okay, for chat model we have input as a string and chat messages as output. For LLM we know we have a single string or list of prompt value and the output is a string. For output parser we have basically the output of LLM as input, and depends upon the parser which kind of parsing we are going to do. Okay, I have made a video on output parser, you can look at it. For retriever, the input can be a single string and the output can be a list of documents, whatever it has retrieved. So this is also an important part to understand, like what are the components which we are having on which we can make these calls, like stream, invoke, we can have chain.invoke, we can have model.invoke, model.stream, all these things. Okay, so after this I want to cover like input and output schema. This is also really important. Okay, so input, I have not went deep into it because I think you already know it. Okay, and if you don't know it, let me know in the comment section. Okay, because this is very basic thing, but it's fine if you don't know it, then I can provide you some resource, and all these things you can all definitely find in the Langchain website. Then understanding the input and output schema, which is very important. So in Langchain's runnable interface allows you to inspect the input and output of any component using input schema and output schema properties. So these schemas are parentic models automatically generated based on the structure of the runnable. They provide a clear description of what inputs the runnable accepts and what output it produces. Okay, let me show it. So just we are adding a chat prompt template. We don't want this system message prompt template and human message prompt template. So we are just creating a simple prompt template, like create a poem of 30 words, under 30 words on this topic, and just we are creating a chain. This is basically LCL syntax that I have covered in the previous video. Let me give it a run. And let me show it the schema of it, the input schema. So here you can see the input schema. Since the chain starts with chat prompt template, the input schema reflects the input required by the prompt, which is topic of the type string in this case. This is the title and this is the type of the input. Okay, so this is how our input schema looks like. Then let's make it the output schema. So it's quite big. So here you can see in the output schema, it describes output produced by the runnable. This is also dynamically generated based on the runnable. You can call dot schema that I have made on it to get a JSON schema presentation. Okay, so this is how the model output schema looks like. Okay, you can just go through it. I'm not going into very deep. Okay, but output schema, input schema is really helpful. Like whenever you are trying to have a definite kind of output, okay, a certain type of output, then output schema is really important. And whenever you will have a proper development journey in GenAI or LLM, then definitely you are going to use this output schema. Okay, and if you want a dedicated video on output schema, the practical use case of output schema, I can also make it. Okay, so till now, if I want to again summarize runnable interface, so runnable interface in Langchain standardize how you create and use different components like chat models, prompt, chains. So think of it as a common set of rules or methods that all these components follow, making it easier to combine and work with them. That's all. Okay, this is the soul of runnable interface. Okay, so I hope our runnable interface is clear till now, but I want to also cover some more things. Okay, so let me cover it. So I want to cover about async stream events. Okay, let me write it. So I want to cover async stream events, which is in beta that I was talking in Langchain. Okay, sorry for my bad handwriting. Okay, so async stream events in beta feature introduced in Langchain like 0.2.0 if I am not wrong. It allows you to stream events asynchronously, which is useful for real-time applications when you need to handle data as it arrives. So, like, it's like you can use this async throughout, like ensure all your code, including tools and function, is asynchronous. It also propagate callbacks. If you are defining custom functions or runnables, make sure to propagate callbacks correctly. Use like there is a method like a stream, if I'm not wrong, for LLMs. When using runnables without LCL, call a stream method on language models to stream tokens instead of invoke. Okay, so like when streaming, there is also, I want to add something like when streaming the inputs of for the runnables will not be available until the input stream has been entirely consumed. This means that the input will be available at for the corresponding end hook rather than at the start event. Okay, what I want to say is like if you are having a, if you are running a tool, then the corresponding end hook will be the like it means whatever inputs you are having for that event, it will be available at the end of that event. Like if you are making a LLM call, then on start you will not get anything, on end you will get something. Like I will show it. So end, that is what I was telling, that the input will be available at for the corresponding end hook rather than the start event. Okay, so I will explain it with an example. What actually are events? There are a lot of events, like some of them, let me write it. So one of them is on chat model start. Okay, so whenever when the model starts working, then on LLM start. So whenever you are making LLM call, this will be the event. On LLM stream, if you are making a stream call, then we have on just opposite of it on LLM end. Okay, I will show some of them. Okay, then if you are having a chain, then on chain start is an event. Similarly, the opposite of it on chain end is also an event, on chain stream is also an event. Okay, so let me show the code, and then maybe you can you will understand it much better. So this is a very basic code. I have just imported something like the first one is phase. It is a vector store in memory vector store. Then we are using output parser, Runnable pass through to pass the inputs in at the runtime. Then we are using OpenAI embeddings. So we are creating a template. The template is answer the question based on only on the given context, and then we will pass the context and then the question. Now we are creating a prompt, chat prompt template from template, and we are passing the prompt. Then we are creating a vector store. So this is a very basic thing to create vector store. If you don't know about phase, you can learn it, or I can create also a video on it. So phase dot from text, we are passing the text and which we are trying to store in the vector store. Okay. Then we have embeddings, and we are using OpenAI embeddings. That's why we have to also pass the OpenAI key. Then we are creating a retriever. So if you don't know about this thing, vector store, retriever, prompt, then please watch my Langchain series where I have explained all these things. So we are having a retriever. Now we are creating a retrieval chain. We are passing the context because we want the context. So context will be this whatever the retrievals will retrieve is the context. Then the question we will add it in the runtime. Then we are passing the prompt, then we are passing the model and standard output parser. You might be seeing we are passing some with config. Okay, so maybe you might be thinking what actually this with config is. Okay, so this with config method in the code is used to add configuration details to the components within the retrieval chain. The configuration can include metadata such as names, tag, or settings that help to manage and track the execution of different parts of the chain. Because we want to track this context and the model, so that's why we are adding with config. So what are the benefits of it? Like the identification, like it's easily identify and distinguish between different stages of the chain when the processing events happen. Like in retrieval, there can be different events. Like first it will add the context or retrieve it, or we can have an event for model. So it helps, okay, to basically observe the different stages of this chain while it process the events. And what are events? That I already talked about it, this all events. Okay, then debugging. So simply debugging by providing clear labels for each component make it easier to trace where issue might occur. Then for logging and monitoring also, this with config can be really important. Like it enhances logging and monitoring by tagging events with meaningful names, allowing for better insights into the chain's execution. Okay, so I will when I will run this code, you will understand it better. Okay, so let me give it a run. This currently nothing will happen because definitely, okay, so there is some issue with the model, so we don't have phase. Okay, so basically I was getting this error in my phase, so I have just I have not done anything. I have just installed this phase CPU. So let me run it again. So there is nothing going to happen, just we have created a prompt, we have stored it in vector store, we have created a retriever, and also we have created a retrieval chain using LCL syntax. Now here comes the important part. Okay, so we are doing a async event. So we are basically this is the main part, the execution part. So retrieval chain, this chain dot a stream events, and basically we are passing like the query, which is where did Harrison work, because in retriever we have stored like Harrison worked at Canshow. So where did Harrison work, then we are passing the version of it. Okay, then we are passing the version of it, and then the include names. So these are the names that we have passed in the config file, which we want to identify and debug, and which we want to trace it or to see how actually things are happening in this events. And so it will run over all the events. Okay, so we have a lot of events that I already talked with you. So we will see like kind is equals to event and event. So what kind of event it is? If it is like on chat model stream, then we are printing this like inside on chat model stream, and then we will see what actually is happening. Okay, then if the event is on chat model start, then we will print it and we will see like streaming LLM. Okay, so we are printing something. Then on chat model end, so we will see like if the model is ending, like we are done with the string, the streaming with LLM. Then on retriever end, okay, so if it is like on retriever end, then we inside the retriever end, and we have retrieved the following documents, and we will be printing the retrieved documents. Then on tool end means it will be it is also event, so we will see the inside tool end and ended tool and the event name. So there can be a lot of events, so in this way you can watch how actually things are happening. So if you see this code, basically there is nothing. Okay, so we are just creating a vector stores and a retriever, and then we are creating a retrieval chain, and here in the retrieval chain we are passing an input which is where and Harrison work. So let's give it a run and let's see what actually is happening. Okay, so it is saying that Langchain beta warning, because we know that this API is in beta. I have already showed you, and it may change in future. So first of all, this question, that is where did Harrison work? So actually these all are callbacks, like on chat model stream, on chat model start, on chat model end. This all are callbacks. Okay, so now for first one is on, because whenever you will ask a question, so it will first retrieve. Okay, because we have a retriever, so it will retrieve the data from vector store. So this one, this one on inside on retriever end, so this will work. Okay, so inside on retriever end, retrieve the following documents and whatever has been retrieved. So it is, see, it has retrieved this one, Harrison worked at Kensho, because definitely we just have one sentence. Okay, but if you are having chunks, it will retrieve the definite chunks, like if you are having a lot of data in vector store. After retrieving, what will happen? Okay, just have a guess. So we will have on chat model start. Okay, so inside on chat model start, the streaming will start. Okay, so we are just printing streaming LLM. Now what next will happen? So we have started the model, so now we will start the streaming, because we have triggered this stream event. Okay, so streaming will happen, and we will move into on chat model stream inside the so it will print inside on chat model stream, and then the event data, the content of event data. So see, it will stream one by one. It's not like at once everything will appear, because it happens in invoke, not in stream. In the stream you see a kind of animation, like slowly the data comes. Okay, it also have its own benefit that I already explained. So first of all, that is just a pipe, and then Harrison then worked at Kenzo. So this was the whole output. So why we are getting this pipe? Because here I have structured in such a way that at the end we will see a pipe. Okay, and every time we will be getting some content. Okay, so every time we are getting some content, like initially there was nothing, that H, then Harrison, that work at Kensho. So then at the end we also have a full stop. Okay, and then everything ends. Now once the streaming is done, because we already have a on chat model start, so guess what will happen? So we will have on chat model end, I guess. So here you can see we are having on chat model end. So done with the streaming of LLM. See how you can track each and every event because of this callbacks. Okay, because of this runnable interface. So how you can track each and every event, like what actually is happening, like behind any stream events, any invoke events, everything, so that you can observe all these things. Okay, and there is also one other thing, which is this one. This one was basically a stream, but you can have like a log, which is very useful. Maybe this video is getting very long, I can explain in some other videos, but this all are very important, because maybe in some case all these events, all these things are taking like a lot of time, like maybe 30 to 40 seconds. So what you want is, like, you want to make your user engaging, and you want to show like one by one, like if some like this whole thing is, let's suppose, taking 2 seconds. So you can just add a like for whole 2 seconds you can add a timer or animation, like half is done, like let's suppose retrieval is done, then this part is going on, and then everything is done like this. Okay, you can make animation like this, and you can make it visible to your user also, like retrieval is done, now we are doing streaming, now everything is ending, so it gives a transparency to the user. Okay, so that's it. Like let me explain some of the events, like on chat model stream. I haven't explained it. So it trigger when the LLM starts streaming a response. Okay, and it prints each chunk of the content as it is generated. Then we have on chat model start, so it indicates that the start of the LLM response generation. Okay, it prints message indicating the start of the streaming. Then we have on chat model end, so it indicates the end of LLM response generation. Okay, then on retriever end, so it is basically triggered when document is retrieved completely. And on tool end, so it indicates end of tool execution within the chain. Okay, and basically here if we again interpret the results, so first of all there was all the documents were retrieved, then LLM starts generating response, that's why we have seen the model start, then all the stream events, and at the end the chat model end. So overall this approach allows you to monitor and handle different stages of the retrieval and generation process asynchronously, so providing a detailed log of the chain execution. Okay, so that's it. Maybe in some other video we can see a lot of different things like async stream intermediate steps, which is really important. We can also see stream JSON path chunks, which is also called as a stream log that I was talking about. And then we can also see parallelism in this runnable interface, how we can execute parallel chain execution or something like that. So this is all about runnable interface. Definitely a lot of things are remaining, but this is the this is something which I want to share with you, like that you should know about runnable interface while you are studying about the LCL. So all these things maybe you might not find useful as of now, but when trust me, whenever you will do these LLM applications development on such things, you will definitely need it, because you need that transparency. You need to see where the things are getting wrong, because it's not always it's like, in my experience I have felt that like whenever you do LLM application development, you might think that okay, whatever I am asking for LLM I will get in that format only, but that's not the correct. Whenever you will do this development part of solving some complex tasks, definitely you are going to, like, you will have a headache that LLM is not behaving the way I want. So at that point of time, you want to see each and every step, where it is going wrong, what it is doing, and each and everything. And also like if you want to do the tracing part, like for this response only, you might be eager that like this event, how much time it took, so you can add the timer in it, and you can just have a tracing that okay, for retrieving it took like 90 microseconds, for starting of this chain, or it took like microseconds, for streaming maybe it took 1 second, and then for displaying it might took microseconds. So in this way you can have a streaming you can have a like logging, or you can have a trace of what actually is happening, and you can trace it, you can debug it. That's why it is very, very important to have the information about runnable callback, runnable interface and all. Okay, definitely 2 or 3 videos I can really post on this, the remaining parts, which is really, really important. I am a big fan of this parallelism and a stream log, so definitely I will create the video on it. So if you like this video, please like this video, subscribe to our channel, and also if you have any doubts, you can ask in the comment section, or whatever your dislikes and likes are, you can ask in the comment section. It really helps us. And that's it. Meet you in the next video. Till then, bye bye. Thank you.